All right, so a review of Algebra 1 factoring crash course, and we've done a lot of these first semester also, so bringing it back into your mind, see if I can do this under 5 minutes. Know that there's other videos, though, that go into more detail for each topic if you need it, but here's a quick overview of all the review factoring you should already know. Okay, so difference of two squares is when you have two perfect squares with a subtraction sign in between, hence difference of two perfect squares. Okay, so this comes from like the formula a squared minus b squared, so it's like your thought bubble. And so how you factor difference of squares is by just taking the square root of both, where in between your terms, one gets a minus, one gets a plus. So over here, the square root of 25x squared is 5x. So that's the a term, if you will, to go from a squared to a. Okay, so square root of 16 is 4. And then one gets a minus, one gets a plus. Because if you were to FOIL this to check your answers, the opposite signs would allow your middle terms to cancel, leaving you with just 5x times 5x, which is 25x squared, negative 4 times 4, negative 16. That's difference of squares. Boom. Done. Okay. X method. So this is when you have three terms, quadratic, where your a term is 1. Okay, so you throw it in your x, where your c term goes up top, b term goes on the bottom, and you're looking for two numbers that multiply to c that add to b. So you go through your list of factors and you're like, oh yeah, 10 and 7 will multiply to 70, but if it's negative, you know one of your signs have to be negative. Well, if it has to add to a negative number, you want your bigger number to match the sign. So negative 10 and 7 are the factors that work because they multiply to this and add to that, and that's how you factor. So x minus 10, x plus 7. Cool. I'm at 2 minutes. This is good. Okay, that's x method. Okay, bottoms up. Probably the most time consuming, but not difficult, but just has a few more steps. So this one's similar to x method, but the issue is your a term. When a is not 1, this is the process you can walk through. Okay, so you can take your a term and temporarily multiply it by your c term. So you do a times c. So 3 times negative 2 is negative 6. And then you do x method with this. So negative 6, and then your b term is negative 1. So two things that multiply to negative 6 that add to negative 1. So we have 3 and 2. And again, if it has to add to a negative and multiply, okay, well, let's start here. If it multiplies to a negative, you know you have opposite signs. So 1 is negative, 1 is positive. Adds to negative 1, you want your bigger number to match the sign. So if it was a positive 1, you would want your 3, the bigger number, to be positive. But it's negative, so you want your bigger number to be negative. So negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. So these are your factors. So x minus 3, x plus 2. But again, that's only if my orange equation was the original problem. This factors to the orange. But our original problem was this blue. So since the a term was annoying, okay, it's not 1, then you have to come out here. You temporarily multiply it in. We multiply it here. Now you have to divide it out. So whatever your a term is. So here we multiplied into 3. Now we divide by 3. So 3 divided by 3 is 1, but you have x minus 1. And then here is bottoms up. This is where it gets its name. 2/3 does not divide, nor can it reduce. It's already a reduced fraction, and it doesn't simplify to a whole number. So you take your bottom number, it's a different color, and you bring it up in front of the x. So your second factor would be 3x, and then the 2 plus 2 stays in its spot, plus 2. And that's how you factor this original quadratic. Okay, 30 seconds. I don't know if I can do it. Let's see. Last method, greatest common factor. Okay, so this should sound familiar to you from Algebra 1 day. So greatest common factor, what you're looking for is the greatest, the largest, common, what they have in common, factor, meaning what goes into both of these evenly. Okay, defines itself in its name. So biggest number that goes into 18 and 27 is 9. So you put your common factor on the outside It's like you're reverse distributing. Okay, and then you're going to put your leftovers, if you will, on the inside of your factor. Okay, so 9. Now let's look at our variables. X to the 5th and x to the 3rd. What's the greatest amount of x's that I can take from both of these terms without going over? So he only has 3 to give. He has 5 to give. So the greatest number I could take from both is only 3. So x to the 3rd. So that's your common factor. To figure out your leftovers, you take your starting term and divide by what you factored out. So 18, you can do this mentally, but off to the side I'll show you what you're doing mentally. And you can always write it out if that helps. But you're doing 18x to the 5th divided by 9x cubed. So 18 divided by 9 is 2. X to the 5th divided by x cubed is x squared. And then you do negative 27x cubed over what we factored out, 9x cubed. So notice here your x cubes cancel and just left with negative 27 divided by 9, which is negative 3. So this is how you would factor using greatest common factor.